Good evening. Welcome to Kepler Educations, and I'm an educator from Kepler Educations. So, this video that we are proceeding with right now is going to be based on the differences between the two forms or the two types of databases that are primarily available in a database system: a relational database and a non-relational database. Relational database as in PostgreSQL, and non-relational database as in MongoDB. Now, this video is going to be based on this particular topic, and the perspective of this discussion that we are going to have right now is from the viewpoint of a software engineer or a software engineering student. For example, the projects that you create in your college life or further, the projects that are provided at respective industries. A question always comes to our mind while selecting something, that what should we use as a database. Like for example, you are provided with situations like we have to create a accounting. We have to create some accounts. Okay, we have to create some credentials. I mean, so a storage that we will have to create an authentication system, let's say, that will authenticate different users. So for that, you will need a database that will store the respective details of a particular person who has signed up to either a particular website, let's say, or a certain particular application. The sign up details of a person will be stored. So that storage should always be in a database, most definitely. So what will be the choice for that particular database? MongoDB or PostgreSQL? That is relational or non-relational. Again, in another situation, for example, you have to maintain, for example, there is several containers, okay, in a multi-containerized Kubernetes system, which is Dockerized system basically, which is managed by Kubernetes. So for each and every situation that this particular flow of containers have to go through, you have to maintain. I mean, if the architecture is microservice based, you have to maintain logs to maintain the error handling. So where will you store the logs? So logs must also be stored at a for particular database. So would you use MongoDB or would you use PostgreSQL? Now, first and foremost, you have to store the logs in a database to retrieve them at a later time. You cannot store it in a file. You can store it in anything. Send anything which is exposed. For example, your file might be in your GitHub. So this is a very important security. This breaks a security feature. So anyway, so basically, what database will you use in order to store these kinds of data? Before proceeding to the perspective of software engineer, uh, we must be aware of the basic differences between these two types of databases. For example, let's say, for example, MongoDB. It comes under non-relational database. Very sorry. These are the basic or the primary differences that I'm going to state now, which most of you should be aware of. It is relational database. Now, on a primary note, what does this mean? This means schema based. And what does this mean? This means object based. More often than not, we do define a particular schema for this non-relational database. However, that is not mandatory. The schema that I mentioned just now is based on the fact that whenever you create a Java, whenever you try to use Mongoose, for example, then you define a schema, mongoose.schema. So there you do define a schema. Let's say the schema is name, string, which you provided your name like Raj Kumar, class, and so on. But name and class, there are only these two, name and class. But you can append a particular data having name, class, and blood group. This is allowed in MongoDB. However, this is not allowed in PostgreSQL. So basically, what is the type of how is the data stored actually? So in MongoDB, data is primarily stored in objects data is in MongoDB primarily stored in objects. However, in PostgreSQL, data is mainly stored in table format. This is something, this is something, this is something, this is something, and these are the rows that are filled in. So this is the most basic or the most primary differences that they have. Many more differences arise. For example, searching in this, whereas searching in this, they are different. Deleting something from this, deleting something from these are different. So we'll come to that one by one. So before going to all those, let me just okay. Okay, so I think this is the primary difference that everyone needs to know. Also, one more thing that everyone needs to know is how the indexing works at PostgreSQL. For example, if this is the primary key or the index, let's say, of this PostgreSQL schema document or table, let's say, then how does the indexing work? I will give you a very brief overview of how the indexing works. Basically, the indexing is done using a B plus tree. Now, what does a B plus tree does? In B plus tree, you store ranges. All right, you store ranges, and from root, and you divide the ranges into various parts depending on some factors. You show these ranges in different parts. Now, each and every lower value, for example, this is 1 to 10. This is 1 to 4, 4 to 5, 5 to 6, 7 to 10. This one comes here, 2 comes here, 3 comes here, 4 comes here, 5, 6, 7. Oh, sorry. This should be 0 to 10 actually. So this will be 0. So 0 comes here. Very sorry, very sorry. 0 comes here. 1 comes here, 2 comes here, 3 comes here, 4, 5, 6, 7, 8, 9, 10, 11. This should be 11. So this is a B plus tree that is created, and for example, I need to find 6. I will cover the length of this B plus tree. I will find 6, and I will go to the corresponding row that has the index 6. This is the most basic architecture. This can be divided into a two-tier architecture. For example, I would first do hashing among these rows. I first do a hashing among these rows, and I divide it into four parts. Divided into four parts, and each of these parts will correspond to a particular index of this B plus tree. Now, after this hashing has been done, this particular segment can be traversed in a linear way. So this is a very simple way in which indexing can be done. But the most important, this is how the indexing is done. And this indexing is one of the most efficient indexing methods or mechanisms that exists in the world. The proof of this particular fact that I have stated right now, or this particular statement that I have made right now, is that this is the actual architecture of indexing that takes place in SQL or MySQL. And MySQL has been B has is in this industry, in this technical industry for more than 50 years. So this is a very good proof or a very good argument to state the fact to mark to for in favor of my in the statement that I gave. Anyway, so these are the most important and the most basic differences that some particular software engineer must know before deep diving into the concepts. Before coming to that, I should also like to tell you that you are traversing the height of a particular tree. Let us suppose I take this particular time to travel this particular segment is k. That is to say that each and every segment, for example, there are four segments. The length of the document is 4k. You get what I mean, I hope. So traversing there are k rows. Basically, there are k rows. So, for example, if I have to find this particular document and this particular key is provided in this index, then what will be the worst case time that is required to travel to find this particular block? That is for searching. You see, it is order of log n for this binary, for this not binary, very sorry, for this b plus 3 plus order of k. We have to keep this in mind. Now, since the basics are now completed, we should come into focus. We should focus more on how a software engineer would handle a situation in which he is provided with a database management task. Like he has to create a database. What should be his choice of the particular database? So it's very important that I am going to say right now. Or I'll say it in the end. You have to find out. I mean, I will tell you. I will come to those points. You see, in what happened in MongoDB. Let's say this is MongoDB. Suppose there are n documents. Let's say, yeah. Suppose there are n doc. Sorry. Suppose there. Sorry. Suppose there are n documents. What happens in a non-relational database is that you start from the top and you simply start moving down one by one. So basically, your time for searching is O of n. However, in Postgres, we found out it is almost O of, it is actually O of log n plus O of k. If we neglect this value k, then we can come up to O of log n in this very simple architecture. In this particular architecture. So basically, what happens is time to search is much faster or much less in Postgres compared to MongoDB. So in MongoDB, searching time is very fast. Conclusion 1. Since searching time is very fast, you can easily understand that when you update something, when you update a document, you first have to search the document, so the updation is very fast. Similarly, when you delete a particular document or a particular value from a row, or you delete a particular row itself, then you have to find first search the row and then you have to delete it. So basically, deletion is also faster. So updation, searching, modification, deletion are faster in PostgreSQL. However, each and every of these operations are very time consuming in MongoDB. So basically, this is conclusion 1. Mark the conclusion is with yellow. Let's say. In MongoDB, updation, deletion, search, mod, whatever, are slower compared to Postgres. So whenever you need an application, for example, login or sign up, storing the sign up data, where people will need to change their phone number or change their name, change their account details. A lot of updation is going on. Some people leave this, but leave a particular. For example, if some people leave a particular organization, let's say Kepler, it itself. So then we have to do, we have to delete the record of that particular person. So deletion is being done. For example, we need to find out if a particular person has taken a course in Kepler education. So what will we have to do? We have to search if the person exists or not, and after we find it, we have to search what are his courses. So basically, we're doing search. So basically, these important details should be stored in Postgres and not MongoDB. However, if there are, for example, logs, logs are very, very rarely needed. A multi-service architecture fails a lot, that is true. But if it is container, if Kubernetes is doing its work properly, then failure is quite rare if the developer has been sure that he has taken care of the edge cases that arise due to not technical difficulties but user error. If the developer has taken care of those particular edge cases, failure is very rare in Kubernetes architecture. So in that case, logs will not be very much frequently seen. So logs should be kept in MongoDB. There is one more important difference. You see, whenever you store something in MongoDB, you write schema. No, sorry, very sorry. You write the key value, you add and the value. You again write the key and the value. You again write the key and the value in Mongo. So let us say if the size is k, you need additional space of c, which is the key space. You need the space of these particular keys. However, in PostgreSQL, the keys are already written at the top. The keys are already written at the top. We just input the values. The search is we just insert the value. So each and every row, for each and every row, the space required is k. And you can definitely say that this key takes an extra space. So it's a very important difference. Storage in MongoDB takes more space for the same entry compared to PostgreSQL. This is the second most different thing that you have to take care of. So basically, okay, so these are the two important differences in terms of software engineering that you have to take care of while building your projects or working at the industry. Basically, storage, I mean, the space for storage is slightly more if the the key names are shorter. If the key names are relatively larger, then a more space is required for each and every document. The storage is more, if not much more, for a particular same data item for MongoDB compared to PostgreSQL. Also, for searching, updation, deletion, and all this function, MongoDB is not as efficient as PostgreSQL. However, only for only for those kinds of data where um, key values are also very small, as well as, for example, logs as the best example. Key values are very small. Along with that, um, there is very rare need of those particular data. However, data will be needed for emergency situations. Data is very important, very sensitive for emergency situations. Then you will have to go for MongoDB. But if updation, search, and all those, I mean, regular activities are required, then Postgres is a much better alternative. So this is one of the very big differences between MongoDB and PostgreSQL. In fact, there was a document. I am not. That was not official. That was an official document. So I won't really use this reference. You can research it out by yourself and mention your answers in the comment. What do you think? I mean, there are two kinds of databases: OLAP and OLDP. Was it called? I guess I actually forgot it. Uh, OLTP or something. I forgot it. There are two kinds of databases, data sets or data types or data warehouses, not warehouses, data directories, let's say. One which is used for day-to-day updates, OLTP, I guess, online transaction platform or something like that. I actually forgot. Day-to-day updates, basically, these are live databases meant for transactional purposes. OLTP it was called. And the other one is OLAP. Let me just search it once. I have actually forgotten it. The names. It should be OLAP and OLTP. Yes, it is OLAP versus OLTP. Okay, it's processing. Online transaction processing and online analytical processing. So basically what happens is that it's on OLAP here, historical data is provided, not live data. Not live data, but historical data is provided, and this data is used for data analysis based on past behavior. Based on past behavior, analysis is done on this particular OLAP database to find out or to predict, to use machine learning algorithms and predict what will be the outcome of the future data. So you can understand, since this is used for transactional purposes, searching, update, deletion is not to be done. Not to be done. No strict, no updation or deletion is allowed because it is historical data. They can't be changed. Only searching is allowed. So in here, MongoDB is the best choice. And I believe majority of these historical databases, people prefer to put these kinds of data sets after they extract the data in the correct format in the MongoDB. However, these day-to-day updates, searching, updation, deletion, everything is highly required. So here, PostgreSQL is the best choice. So this is a very important thing. The OLAP is stored in MongoDB preferably, and the OLTP should be stored in PostgreSQL preferably. Now, also, this is a very generalized okay. So basically, the thing is complete. The differences, the importance, the software engineering perspective is completed at this point. Now, I want to tell you everything that software engineering is a domain that depends on the developer majority for the majority of the viewpoint. Like uh, I mean, it completely depends on the developer. Whatever the need is, whatever the situation is, the developer has to understand and he has to take his own decision. It might happen that very high searching, addition, deletions are required, but still you use MongoDB. You prefer to use MongoDB. So at the end of the day, it is the developer's choice. Based on the market, based on the needs, the business needs, and each and every other detail the developer has to focus upon. He has to decide whether he will go for MongoDB and PostgreSQL. Whatever I've said just now is a very generalized overview of what is supposed to be used in a general situation where the constraints are the searching, deletion, updation, and all those that are specified. But this might not be the case. This happens majority of times, but this might not be a case of a particular business needs. So this is not final. And the final decision always lies with the developer. So this was all that was supposed to be told on these differences between MongoDB and PostgreSQL. So I will conclude the video here, and this is the first video of this particular part of Kepler Educations, where we try to provide some knowledge based on some recent developments or problems that are going on in the software development fields. Many such videos will come up very soon that will tackle live problems or that will tackle actual development problems that developers have during coding. So before ending, this is our official website. I will put this particular notebook in there as well as the recording of this particular video in there as well. So you can go there and watch it. So yes, that's all for today. Thank you. Have a good day.